সেন্টার যদি এরকম হয়
Good morning, respected faculty members.
Hello, Dr. Satish.
I'm Rajesh, Department of Civil Engineering, Kallam Harnath Reddy Institute of Technology. Today's speaker is Dr. Prabha Mohandoss. Let me introduce about her. Dr. Prabha Mohandoss, a senior project officer at IIT Madras. She have taken a leadership role in managing and overseeing projects within the institute. This position has allowed her to utilize extensive knowledge and skills in civil engineering to contribute to the successful execution of research and development initiatives, and her all-round performance award in PhD category in IIT Madras in 2018. And also she got a gold medalist and university rank holder for the academic year 2011 to 13. And also she secured first rank in her masters at Anna University. And also, through her diverse roles at IIT Madras, she have gained a comprehensive experience in project management, research, teaching, and academic supports. These experiences have shaped her into a well-rounded professional in the fields of civil engineering. She holds a PhD in civil engineering at the prestigious IIT Madras, and she completed her master's in structural engineering from Anna University. Overall, Dr. Prabha Mohandas' educational background has equipped her with a strong foundation in civil engineering, particularly in the areas of concrete, structural engineering, and pre-engineered buildings. Now, I'll hand over this session to Dr. Prabha Mohandas. Thank you, madam.
Thank you, Dr. Satish, for the nice description. So, you can start the session, right, for today? So
Yeah,
let me
madam, you
share
can
the
start.
screen.
You can start the session, madam.
Yeah, I just want to share the screen.
Okay, madam. We are
So,
giving you.
yeah, disable to share. So, can you please give me access to share the screen?
Yeah, madam. We are giving access to you. Please share the screen.
Yeah, fine. So, have my screen is visible?
Yeah, madam. It is visible.
Okay. So today I'm going to talk about the modern construction materials that we typically use in construction practices and then technology that we adapted towards sustainability. So is my voice audible to you, sir? Is it clear? Or should I
Yeah,
be
sir. Yeah, madam. It is clear.
fine? So nowadays we talk a lot about sustainability, right? The circular economy and sustainability to enhance the performance of these structures. So in this lecture, I'm just going to touch few details upon the advanced materials that we will be using in the construction practices, and then the latest technology that we adopted to enhance the construction and practices and performance of the structures. I hope many of you might the technology course. So I'll and then the types of reinforcement. And these are my general presentation outline. So first, I'll touch the importance and roles of materials in the construction practices or the structures that we adapt, right? And then after that, I'll be talking about the challenges in meeting the required performance. So we tend to construct buildings a lot, but then the serviceability of the buildings are still questionable. So we construct buildings to last for 100 plus years. Then we tend to observe a lot of degradation and performance issues. So the challenges in meeting the required performance will be addressed, and then with advanced concrete systems in perspective of the pre-stressed concrete technology, and then if in case if your structure is repair, then the self-healing concrete would help to enhance the performance. And then the current trend on talking about the 3D printing concrete as well. This is with respect to the concrete system. And when you look at the significance of reinforcement, we know that we have various types of reinforcement, various types of rebars that we use in our construction practices. So we look at those types as well, and in general the practice care that we need to adapt for those reinforcement, and then the quality check or the assurance that we can take care to enhance the performance. So to start with, so you all know that India is witnessing a construction boom irrespective of constructing a few large highway structures, seaports, airports, residential and commercial buildings, urban and rural project schemes, and the one of the prime scheme of the mantra scheme is that housing for all, mass construction. So in all these things, we need involve a lot of construction details and then lot of materials being used. So the cost involved in those projects are going to be enormous. So it's very important to take care of the construction and the materials that we are going to use in the structure to enhance the performance or to meet the required conditions to stay there for long period. If not, what happens that we tend to observe a lot of degradation or issues over the time, and we tend to spend a lot of money over the period to keep up the performance of the structure. That is one thing. Or else we don't care of those structures after the construction, and that is going to degrade and the performance is not going to meet, and in certain cases we fail, you know collapse and a lot of accidental issues as well, and which we don't want to occur. So what we need to do is we need to keep them safe and usable for a long period, say for several decades without much maintenance and repair. This is what we talk about the sustainability. So the sustainability means that whatever that we do, so that the sustainability is such a beautiful word that we can relate with all our day-to-day life, the sustainable lifestyle and sustainable eating. So in civil engineering, the sustainability is all about how long the material can, how long the structure can stay, how much energy that you can reduce to enhance the performance. So how much raw source materials that you can save, and how much CO2 emission can be controlled. So everything that put together is what we call as sustainability. So that starts from the scratch to the entire performance of your structure. So typically we call cradle to grave performance. So from the baby to the how it is going to perform. So the scenario, what is the scenario? In today's scenario, so for example, if you take any bridge structures, there are some partial data available that was collected from it. So this is from the centralized course material. You can go through some of the things where from the Professor Pillai's material. So he talks about the survey of about 1.7 lakhs bridges across India. It says that about 6,000 bridges are structurally distressed. So this is based on the data that was collected by Indian Bridge Management System Program and the Ministry of Road Transport and Highways. However, these numbers could be enormous based on the real scenario, which we could not get the actual data. So actually this could be even more because the database itself are inadequate and could be incomplete. So if this is the scenario, what about the buildings? So buildings we don't give much care, or the government sectors to take care of the buildings unless because it becomes as more of individual property that we need to take care of our buildings. So it's going to be a Herculean task of maintaining such existing structures, especially the infrastructures, and building new ones with durable um, consideration and corrosion resistance in consideration. Why the corrosion is going to become the attention here is that India is a region where the three sides, have. So it has a long coastal regions where the structure that we are going to construct is going to withstand aggressive environment, or going to expose to aggressive environment. So the care should be given to provide such corrosion resistance performance as well. The importance of concrete system is that the reinforced concrete structures are expected to be there maintenance free for the long period. However, evidence of premature deterioration of modern structures are being observed, and then the resultant cost of the economy reaching will be about 3 to 5% of the national GNP. In some countries, it is about 50% of the construction budgets as well. So existing knowledge are not adequately applied as well. So now let us talk about the scenarios in concrete, which need to be addressed to take care of the performance. So the different conditions and problems in RC members are you have a outside region that is typically called as cover grid. So you might be knowing what is the cover that's provided for a structure when it is being constructed in different environmental conditions, whether it is going to be the environmental conditions mild or severe or moderate. So depending on that, it is going to be.
Madam?
Sir, is my slides are moving?
No, madam. The slides are not moving.
Sir, okay, I'll just check. I'll just stop and reshare it.
Yeah.
Are you able to see the screen?
No, madam. It is not visible. You can restart the slideshow.
I thought
Just
it is being moved. Because I'm not able to see the chat also.
madam, screen not visible, madam.
Is it visible now, sir?
Yeah, madam. It is visible.
But can you see the screen moving from one slide to the other slide?
No, madam.
Okay. Let me share it. I'll better share the entire screen. Are you able to
Yeah,
see now, sir?
yeah, madam. Yeah, it is good.
Thank you. So if there is anything to be, such issues, please let me know.
Yeah, madam. Sure, we'll let you know, ma'am. Yeah, madam. You can continue.
Notification from one of my friends saying that it is not being moved. Thank you. So in the concrete system, so the better is that when we talk about reinforced concrete members, you'll be placed inside the concrete. So we typically cover, like you can see this rebar placed inside the concrete, and then you have your concrete placed here. So the concrete is going to basically cover your rebar, and that is why we call this region as the cover creep. So depending on or severe, you vary or you increase the go up to for a cover plate, because if you increase too high, then it is not good for your concrete. Why? Your concrete is weak in compression, weak in tension and good in compression. So as you increase the depth, that concrete region may not withstand the tensile stress, then you may end up having a lot of spalling in the covercrete region itself. So when the covercrete region spalls, then that is going to expose your rebar to the outside environment, and then the aggressive agents would react and affect your rebar to induce the durability issues. That is what being illustrated here. So this dotted line basically indicates the region that is outside. Here you have the concrete surface. So this is going to be exposed to the region where your concrete may get dry, and the water inside the concrete mix may get evaporated over the time. And at the same time, so from the outside environment, you may have ingress of aggressive agents like chlorides, water, or carbon dioxide that can come in and that can react or attack your river. So this all depends on the porosity of your concrete, and then the connectivity between the porosity, which will lead the path for this aggressive environments to travel through your concrete matrix. So this concrete, typically the covercrete will be like poor quality near surface concrete, and that is why we give a lot of emphasis on curing. So if you need to provide adequate curing, so that the evaporation will be from the water that you provide to cure your concrete, not from the concrete itself. If concrete loses its moisture, then it is going to affect the strength gain and the durability also. So that is why this becomes curing affected zone if the curing is not done properly, right? And then this is going to become poor quality near surface concrete, and eventually that will lead to a lot of issues to the rebar. So inside we typically call it as a bulk concrete or the core concrete that is there inside, that will have good strength compared to the covercrete. So that is why we need to understand that irrespective of the region out or in, the quality of the concrete should be good. That can be achieved only if you provide adequate curing to enhance the performance. For sustainable structures, and good quality of the material should be used, so which helps you to achieve the required conditions. So we can divide into two categories. One is the concrete system. So that depends on the materials. What are the materials that you use, type of binders or type of contents, aggregates, admixtures, and of course the mix design in which are the proportions that you use to achieve the target goal. And at the same time, the process that we use to mix your concrete and transport it from one place to the other place and compact it, curing and temperature and workmanship, everything will have its impact on the performance. So when you consider the environment, we can categorize into two categories, physical and chemical. When you talk about the physical conditions, that could be due to abrasion, erosion, cavitation, and freeze-thaw cycles as well. When you look at the chemical, that is about dissolution, leaching, expansion, and alteration. So this is because with the aggressive agents that get into a concrete, and that may result in these various conditions. So when you talk about the concrete, so this is from the book. So now concrete structures will be all porous. It is highly heterogeneous materials. So the pore connectivity will lead to permeability, and then if the concrete cracks, so you can see a mild crack formations. If the concrete cracks, that may lead to chloride ingress, and that may lead to oxygen ingress to your material, and then depending on the environmental conditions, you may have saltwater penetration, carbonation, and water saturations, and these are like external condition. And if you talk about the pores and due to cracks, so the materials that you have may have some alkali content in cement, and then may have some the interior ingredients that we use in concrete. So the cement will have alkali in it. The aggregates may have silica in it, and depending on the favorable conditions, you may end to have a sulfate attack as well. So these things, when you have the combination of oxygen increase, chloride increase, salt water penetration, carbonation, that may lead to corrosion issues. Whereas if you look at the water, alkali, silica, in these combinations, so this may result in alkali aggregate reaction, ASR conditions. On the other hand, if you have only the water saturations, that may result in leaching, and when you have sulfate attack, that may result in concrete expansion, and eventually that is going to crack your matrix. So if that is the case, the cracking will be there, and that is going to result in strength loss, and once that is lost, then the material is going to slowly deteriorate. So what is the common cause of the materials? So sometimes we are not so aware. This is from Professor Bashir plan UK. So based on the fine, it says about the 33 percentage, the major contributions are due to corrosion effects. The external fluorides would induce the deterioration, and the rest of the things were mainly contributed by the shrinkage effects and then the corrosion due to carbonation and alkali aggregate reactions and abrasion and emulsion. So if you look at the major cause would be like corrosion due to external fluorides and corrosion due to carbonation and corrosion due to inbuilt chlorides. So that is going to influence the durability performance a lot. So you might have observed in your day-to-day life the structures that surround you. The corrosion will be one of the common issues that you can find. So what are the factors that contribute such concrete deterioration? So one is that low cover. So typically to save material, people don't provide adequate cover as required for a particular scenario or conditions. So when you tend to provide low cover considering the cost and the factors and everything, you may save cost in the initial stage, but at the end, when you look at the overall the life cycle of your structure or lifespan of your structure, you may need to spend a lot of money at certain interval or frequency to enhance the performance. So low cover is not good. So you provide adequate cover. So low cover or high cover, both extremes are not good. So you need to know what are the adequate cover for the particular scenario, and that need to be provided. And then poor quality concrete and poor design detailing and poor workmanship, wrong specifications, and failure of joint waterproofing and wrong material selection. So this all because of the awareness that we have with our the design people or the site people, and then the workmanships. So the designers will think this will work, but when it goes to the site and the site engineers may not be knowing what exactly the designer thought and included, and there will be a compromise in the performance, and especially at the end, who is going to construct it? The layman is going to do construction, and some of the says you may observe that if the concrete is not flowable, the layman don't even think on adding a water. He just pours a water to make sure that the water is more flowable or something, but he doesn't know what he's doing. But if you look at, then that is going to change the entire material composition and design, and that is going to affect the strength and durability of the material. So at the end, it is there in the hands of the people who are going to do the construction actually. So that's where the major thing comes, the poor workmanship and wrong specifications. So sometimes we need to know what type of material would be suitable for certain applications. We cannot use all the materials for all the applications. We need to know the pros and cons of the materials, and we need to choose the materials appropriately so that the material will withstand in certain applications meeting the requirement. Right? So what do we need to consider? We need to choose a balanced approach to enhance the service lives. When you talk about the balanced approach, we need to care of steel. So of course, we are thinking that the steel is being taken care by the cover grid by covering the concrete on top of it. But we are not taking care of the cover grid. So when you need to look at the service life, it has to be balanced. You need to take care of the steel as well as the concrete. So the steel with enhanced resistance against corrosion, and the concrete, that is specifically the cover grid with enhanced resistance against the ingress of deleterious elements. So this is what considered as synergetic effects to be look at. So why concrete? So why do we? So you might be so curious to know why concrete is being used tremendously in the construction field. That is because if you look at the price of the concrete is one of the cheaper material that serves for all the purposes. So this is the range that is given by Ford. You can look at for annual production tons per year, ranging from the titanium, aluminum, steel, wood, bricks, concrete. So the concrete production is enormous, and the cost is also less. So if you look at the energy wise, so the required for this also is less compared to the other materials. So thing to note is that produce concrete, you need to have cement. The cement demand across the globe is also given here. So you can see around it's just the prediction over the decades, ranging from 1990 to 2050. So the China is the highest cement producer, manufacturers, and then we have, and then other developing countries together. The cement demand is this. So the point here is that the production in cement is enormous, and likewise the CO2 emissions from the cement is also enormous. So when we talk about the attributes of the concrete, so it is the second highest consumed material next to water. So then imagine how significantly we use concrete in all the structures that we use, and then the amount of cement that goes in, and then the CO2 emission in association with it. This is why sustainability is in a talk how well that we can reduce the CO2 emissions from the cement and how can make the material be more sustainable. So what are the desirable qualities? You need to enhance the workability for concrete. Any concrete to perform well, the fresh property is the workability, and then compressive strength, then durability, and emotional stability. So these are the primary properties of concrete. And to adequate, to develop the infrastructures, the concrete has taken out various shapes. So ranging from the normal concrete, high performance concrete just increase the strength. And ultra high performance concrete, the strength can be tremendously increased so that the size of the member can be reduced to save the that load and then the cost as well. Then we have precast concrete systems, then self-healing concrete and 3D printing concrete, right? And what about the reinforcements? So in reinforcements also we have various evaluation of reinforcements starting from conventional steel rebars, then coated steel rebars, then FRP bars and strands, and pre-stressing strands. So normal strength concrete, I don't need to give you any definitions. You might be knowing what normal strength concrete is. So I'll focus on the high performance concrete. So you might be knowing what supplementary cementitious materials, right? So there are materials that possess certain characteristics of reaction in the presence of water that to produce the hydration product similar to your cement. So this is what we call supplementary cementitious material, and the whole reaction is what we call is pozzolanic reaction. So the material that attributes this pozzolanic reaction is called pozzolanic mineral admixtures such as fly ash, GGBS, rice hash, and silica fume, metakaolin, and fume. So what is the advantage of using such materials is that so when you use such materials, these are going to be finer than your some materials are finer than your cement particles, so that it will go fill in the pores and that will help you to get a dense packed structures. And some materials will react with the calcium hydroxide in your cement and produce additional CSH, and that will also help you to get more pore refinement and get more denser matrix. So this requires proper curing to avoid early cracking due to shrinkage and thermal stresses, because when you use such materials that need to taken care properly, then you have ultra high performance concrete. So when you have ultra high performance concrete, that is going to be based on cementitious composite material. You have certain discontinuous fiber reinforcement placed. So the strength typically are in the range of above 120 MPa. So nowadays ultra high performance concretes are being used enormously for constructing high-rise buildings, so that the size of the buildings can be reduced significantly when you move with UHPC, and such things are helpful to reduce the overall dead load of the structures. So the pre and post cracking tensile strength would be above 10 MPa, and this helps you to have enhanced durability, because when the strength is increasing, the stiffness of the material will also get increased, and then the material behaves more stiffer. So adding fibers will help to bridge the cracks, and that will help you to enhance the toughness of the material. So that's why in combination of these things will help you to achieve ultra high performance. So typically here you can see it's a combination of cement and porcelains, water, and of course here the water. To achieve the high strength, the water cement ratio will be lesser, so you need to go with high range water reduces and fine aggregates. So you typically reduce the coarse aggregates in this when you need to go with high performance concrete, and then the fibers in it to measure quality. So let us compare the performance of the ultra high performance concrete here. So it's conventional concrete, high performance, and ultra high performance concrete. So the strength would be for the conventional concrete in the range of 20 to 50, and for high performance concrete it is about 80, and for this ultra high performance concrete, this is rapid powder concrete that is mentioned, it's about 200 MPa also. And flexural strength it is 2 to 4, and here it is 7, and ultra high performance concrete is about 10 times the conventional strength that we have, and modulus of elasticity in the range of 30 for conventional, 40 for high, and about 60, twice the conventional strength for the ultra high performance concrete. So these structures will be very helpful when you need to have abrasive wear in structures, and then when you in such scenarios the water absorption will be 7 times slower, and rate of corrosion will be 8 times slower, and chloride ion diffusion will also be lesser. So the fibers are basically, helping the enhance the performance. So this is what here it is expressed here. So up with this, the concrete has a major role, and then the fibers will start bridging the cracks, and that increases the toughness in your material. So now let us talk about the self-healing concrete. So what is so special about the self-healing concrete? So especially when you need to take care of these structures, for example, the bridges. So you construct it and you construct it there for 100 plus years, but after 10 years or 15 years, you start observing some, issues with those structures due to material, or that could be due to construction or any insufficient design appropriateness could be. So in such cases, when you have this such self-healing concrete, so it repairs itself. How does it repair on its own? There are two types of healing. One is autogeneous, another one is autonomous. So when I talk about autogeneous, it is about the inherent ability of your material to do healing on itself. So cementitious materials, that is for the, so when you talk about the cement, so not all the cement particles will get completely hydrated when you do the process. There will be some unhydrated particles also. So when you have a crack, and when the unhydrated particles exposed to the region, and especially if there is a water, and they tend to react and then form further gels to fill up the crack. So that comes under the autogeneous healing. And autonomous healing, there is a trigger. So you activate something so that there is some reaction that will be induced to repair the crack. So embedded unconventional engineered additions rather than unhydrated cement, it has the potential to repair larger cracks. So these things, so you can use self-healing as a control measures. This could be capable of repairing cracks within a few hundreds of micrometers. Meaning, if you have a structural damage, which is in some several, crack width, or cracks falling or something, in that cases this will not be helpful. This is as a maintenance and control purpose. So in the initial stage, if you have such mechanisms that will help you to reduce the cracks, minor cracks, which further will be prevented to have a crack growth that will result in a severe crack in the later stage. So if we look at the mechanism of autogeneous healing, so we can classify this into three categories. One is physical cause, then chemical causes, then mechanical causes. The physical cause, what happens basically is just the swelling. So some material gets in and it swells. So as it is going to react, there will be a continuation of the hydration, and as it is going to hydrate more and more, that is going to produce the hydration products, and those products will fill up the crack. So this is one way. And the mechanical causes, if you have originally in the presence of water, and that is going to break some fine particles, and that is going to accumulate over the time, then that is going to fill up this region. So if you look at the external categories, the performance of healing materials in self-healing concrete is that you can have some concrete with mineral admixtures. The crack after damage is induced, and then now you can see the expansive agents. You can feel some geomaterial swell that can eventually swell and fill up the crack, and this expansive material agents and geomaterials and components eventually fill the crack completely. Right. Similarly, here you have damaged ECC of crack with less than 60 micrometers. So in this case, if you have a healing product that would fill up the cracks when it is being exposed to the water and air, this is how your structure is going to look at. So the lesser size of cracks means lesser amount of healing material, which is in turn required to higher healing efficiency. So the self-healing concrete concept works better when you have less smaller cracks, and over the time the smaller crack will be controlled or that will help to prevent the crack growth or severe crack formations because of that reason. Right? So what are the latest technology that we use? The current practice is that 3D printing concrete technology. So we are so tend to print, or we are so tend to get some 3D models or those things commercially available for all the applications. So when you look at our civil engineering applications, is it possible to print a house or print a model, something that huge, to a real scenario? So this, if we talk these things 20 years or 30 years back, people might have said it's new. It's a big no. It's all start with a small, innovations and connecting things here and there. That's how stereolithography and fused disposition has prevailed over 1980s. But in those times, that was not popular in construction industry. And Cosinas, so he is the pioneer in this area called the contour grafting. So he related the potential of this additive manufacturing technology to the construction field. And later, a lot of people start working on how this technology would be helpful for the construction field, and they have come up with extrusion based 3D printing models where cementitious materials will be passed through a nozzle, and the nozzle will be sprayed or deposited through the required. So in 192014, sorry, in 2014, Vincent printed two-story building houses in a Chinese construction company. What is the advantage of using 3D printing concrete? So it increases the geometrical freedom and reduces the human labor, and thus the poor workmanship thing, and it's fast and time effective and low risk, etc. So you can look at it. So this pie chart shows you when you go with 3D printing concrete, you can save the labor cost for form work would be about 50%. And this one, it's a concrete material cost would be 30%. When you go with 3D printing concrete, we avoid coarse aggregates, right? And then the concrete labor cost. So the labor required to concreting will also be saved. And then the material cost for formwork, you don't need formwork at all, right? So those things will be saved. How does this work? So this is based on a rheology, and then you need to customize the rheology of the material. So the additive materials that you use in the cementitious material, that should have a free flowability, so that when you spray the concrete, that can freely flow. It comes through the nozzle and it is being placed to the layers and required shapes. So if you look at the material behavior, the yield stress and viscosity are the two primary properties that we need to look at, which should be low during pumping, while immediately after deposition, yield stress should be higher of magnitude. And this is achieved by adding an additive. The additives should control the flowability of the mix that is going to come through the nozzle, which increases in yield stress and elastic modulus. So accelerators can be added so that the strength gain will be significantly high, so the layers can withstand there once it has achieved the strength. The most common method for accessing is that extrudability is based on printing a filament layer. So in that case, when you do it, you can visually examine the layers as well. Is there any sign of blockage or tears or discontinuity? The buildability depends on the number of layers that you construct for the printed formation. There are test methods available to check the conditions, and then to ensure the performance of this additives that is coming through the nozzle is appropriate or not. So based on this technology, in India, IITM startup builds India's first 3D printed house in 2017, and then later it's a house in IIT Madras, and there is a startup who works exclusively on this. So that's why now the company has grown a lot, and they do a lot of 3D printing working across the India. So in this, from their study, they have found out that using this 3D printing technology cuts down the construction cost by 30%. So recently, you might all be aware of this India's first 3D printed post office. This is being constructed in Bangalore by L&T Construction. So it is a 1,100 square feet structure which was constructed about 23 lakhs in 45 days. So the advantage of this 3D printing technology is that you can construct the building in very few days, but then the planning should be done properly. So the planning and designing should be done properly to execute the things. But when it comes to the execution stage, you can implement in a very short span, and then the cost involved also less, because you optimize the materials and you cut down the labor requirement as well. And another major advantage is the aesthetic appealing of the structures. So you can use the best of concrete when you go with 3D printing, because concrete is good in compression. So when you curve it or when you do these abstractions, you are going to make use of this compression effect. So you will be, better using the concrete. At the same time, you are enhancing the aesthetic appearance of your structure. There is another footbridge in ETH juries. So you can see the shape of the structures, how unique these structures are. Similarly, nowadays a lot of 3D printing structures are being constructed, and there is one largest bridge is constructed in China. So the whole concept here is that when you go with such things, initially you may not be using reinforcement, and you are reducing the cement content as well. So these things will eventually lead to approaching sustainability practices. So this is with the concrete. So now let us look at certain practice that we can adapt for steel rebars that will be helpful to meet the quality conditions or assurance. See, sustainability comes when you do a proper quality control and assurance as well, because by doing it, you are making sure the structure is going to stand for a long period without any energy required from the surroundings, or without any harm to the external surroundings or trouble or whatever that that is going to affect the functionality of your structure. So now we'll look at the thermomechanically treated or quenched self-tempered bars. So you might be all aware of what TMT bar is, and many of you know how the TMT bars are being manufactured and what are the key things that to look at. So in sum, I will quickly tell you what is the process that is involved in the making of TMT, and what are the things that we need to look at when you need to qualify or when you need to assure the quality of your TMT bar. So you can see this process table. So the temperature will be initially increased significantly high, and then it will be quenched. Then it will be kept in the atmospheric condition, so it will be tempered. So by doing this process, your surface will be immediately you can see the effect of this whole temperature process here. After rolling, you may have the both surface and core material will be the austenite, and in the quenching pulps, what happens? Your surface becomes, they immediately quenched, so that becomes martensite, and your core will still be in the austenite stage. And when it is being kept in the tempering bed, so now this is going to slowly, emanate the temperature from the surface to the inside. So the martensite will become as a tempered martensite, and still your core will remain as the austenite. When it becomes, when you do a cooling process, so my tempered martensite will be still the same, and slowly the temperature from the surface is going to get penetrated to your thing, so that it will be disseminating the coolness will be disseminating through that, so the core becomes the ferrite and ferrite. So when you cut and look at the cross section of your TMT, you'll be having the inside ferrite perlite face, and then the outside tempered martensite face. So this is what we call it as TM ring, right? So TM means tempered martensite, so it forms a ring around this core, so that is what we call it as TM ring. So to qualify the TMD bar, we do check for TM ring formations. So before getting into that, I'll just briefly tell you the advantages. When you go with TMD, compared to your conventional bars, it will have low cost and high strength, and mainly it has enormous ductility that is good for the earthquake prone regions, and the elongation will be about 80 to 30%, right? And since there is no cold working, and it provides better corrosion resistance also. So how to identify or select the TMD bars? So when you need to select TMD bars, you need to select only if the hardened periphery and soft cores are uniform and concentric. So when you do the check, so I will explain you the TM ring test as well. So when you do the TM ring test, you need to have the TM ring formation on the outer surface, and you need to have this FE phase in the core. But it should be the consistency. So there should be allowable range. So typically when we go talk about this hardened phase, so hardened phase is here is that the TM ring. So the TM ring should be ideally about 20 to 30% of the total cross section, and then the inner section should be more than 60%, so that the ductility will be more. If it is not the adequate level, then you may compromise the ductility. So these things can be identified using TM ring test. So now what is TM ring test? So for doing TM ring test, so you cut the rebar and place it in this form. So you prepare the surface, you cut it and you polish it, and that will be exposed to 5% of nitrile solution for 5 minutes. So once you do that, and you can see the phase distinguishing between the outer TM ring and then inner FP phase. So to be more clear, so you can keep this prepared specimen under this testing adjustments, sorry, testing setup. So you can see arrangements for looking at the details of your specimens. You have a camera and you have a lights placed on it, so the image under the specific lighting conditions will be helpful to look at the TM outer and FP inner face. So here these are some examples where you can see a good TM bars and poor TM bars. So nowadays you might have seen a lot of advertisements saying that the TMD bars are qualifying the TM ring test. So those are based on this test methods. You cut it, then you see the microstructure to indicate the TM ring outer surface and FP inner surface. So this shows a good uniform hardened outer surface of the TM face and then inner core FP face. Whereas here, this is an example for the poor quality rebar. So the ring is not uniform or consistent around these things. So here you can see the thickness of the ring is less. Here again you can see there is no TM at all, and here you can see the same scenarios. So these indicates, the red dots indicates the peripheral regions with imperfect TM phase. So better quality control of TM scale is essential through regulations and more awareness. So Professor Pillai extensively works in this TMT, quality assurance testing. So test method is also proposed on the same TM ring test, a quality control test for TMT bars. So now we collected a lot of rebars from different manufacturers to check how well our bars are in our market, and to come up with that, what we observed is certain manufacturers are doing good, and then the products from those manufacturers are satisfying the required conditions or criteria by providing a uniform TM ring with the proper soft FP. Whereas these other manufacturers, the quality is not met. That is because the awareness is not reached that well to ensure that the phase should be in this range and then the TM ring should be this range. The one interesting fact is that this is more irregular when the diameter of the rebar is less. As the diameter is increasing, this would be controlled a bit better. Other than that, so this TM bars and those things, we need to have a surface cracking check. What we need to do is, we have to bend the crack and see if there is any cracking on the surface or not. So we bend the bars like this. You can see the cross section here. So this is the good cross sectional bar. When you bend a good cross sectional bar, you will not see any cracking on the surface. Whereas if the cross section is not good, that is, if the TM ring is not uniform, and when you bend it, then you will be seeing a lot of severe cracks like this. So this is going to affect the durability performance of your structure when these bars are going to be used in such applications. There is another thing to notice, that these bars are going to be used as stirrups also, right? When you are going to use stirrup, you are going to bend the bars like this, and when you bend it, and there will be a crack, right? So as a quality control check, the code suggests you to bend at 135-degree angle, and if there is no crack, then it is good to be used as a shear with stirrups. If there is a crack, then you need to be precautious, and you need to take additional care to prevent any issues, and especially when you are going to use it in the earthquake prone regions, right? So in such cases, these things are very crucial. So how do you do the bend test? So IS 1608 gives you the specifications to do the bend test. So when you do a bend test, the specimen is considered to pass the test if there is no crack or rupture. So you have a mandrel diameter like this. So you keep your rebar going through that, and then you bend it to 135 degrees Celsius. The mandrel diameter should not be too large. So you have to keep a relationship between your rebar diameter and then the mandrel diameter, which will be to induce the stress on the surface. Now, another technology is that we know the conventional rebars, when it is being exposed to the chloride or moisture or oxygen, that is going to result in corrosion. So how can we control it better? So we can coat it, right? So that's how this coated technology has come up. So it has come up as a protection mechanisms. You can see here, this is your steel rebar, and then you have a coating, and then you will be having your concrete. So in this case, the protection mechanism is that first of all you have a concrete as your cover crate to protect your rebar. In addition to that, you have a coating. So even though if there is something that comes in through your concrete, you have your coating to be, protected between the coating to be protected, protecting your rebar from the external source. For example, if this coating is not there, if there is a hole or if there is any, path in which the aggressive agent can get in and that can get into your steel, that's where the problem comes, right? So we'll address those things in the coming slides. So the concept here is that the protection mechanism is to eliminate the direct contact between the metal and electrolyte, and then reduce the reduction in the driving potential by the protection film around the steel surface. And in this case, when you have such arrangements, there will be a reduction in oxygen supply. So people thought these things will be very good to protect your steel, and this protection technology has come up. And you can see a lot of manufacturers in India who use this FDP coating process as well. So how it is being coated? So it's a blast plate. So once you get your rebar, epoxy resin powder is ionized and attracted to the steel surface by electrostatic force. Then you do water quenching in a thermosetting polymer. And then you do inspect. So here this person is doing inspect for holiday or damage. So holiday is not the holiday that we usually take. It is the name that is given to the pinholes or micro, damages, so that need to be inspected. So for a certain length, you have some allowable limit of the holidays or damage to have, that is less than 1.1% or something. So if it is more, then that is going to accelerate the behavior or the corrosion in a negative way. So here is the thing. So it is the microscopic image of the coated surface. You can see a small pinholes. So these are called the damages or the holidays. So when you do inspect, how do you do it? So you have a wet sponge, and then you have this wire brush, and this will be connected to it, and then you check it, and this will indicate the, indication of the damages on the surface. There are a lot of poor practices also we observed in site. So mostly rebars are cut at sides. So when you do cut at the sides, there is a possibility if the coating is thickness is more, they may get peel off. If it is peeled off and people may not think further, they just tend to fix it then and there and they recoat it. And the recoating is going to affect the performance mostly. So the curved surface is applied using a simple paintbrush designed at ambient temperature conditions. So fusion bonding will not occur at ambient temperature conditions. So these things will not going to serve the purpose. So the advice is that the FPC rebars must not be cut and bent at the site and must be handled delicately to avoid surface damages. So typically manufacturers, they do supply the materials in required bent angle, or if you need to have the bars as a stirrups, you can give your specifications. They can, bend the bars to the required geometry or those things, and those things can be done in the manufacturer unit itself. Why? Because they'll do all the process before the coating itself. The bending will be done before the coating, so that once it is bent, then it is easy and smooth to coat. So the coat will stay further. But here you can see you have a straight bar, and then the practices just want to use this as a stirrups, and they are bending it at the side. So when you bend it, what's going to happen is that the bent regions are going to crack because you are having some epoxy material on top of the steel, and when you bend it, the steel can withstand the bend, but the coating cannot, and that will have such poor cracking on the surface. So when you have such cracking, and that is going to accelerate the corrosion process by inducing more anode cathode, or the ratio between the anode cathode will be higher, and that will accelerate the problem. So additional epoxy coating using simple paint brush at ambient temperature does not lead to fusion bonding, and it should be avoided. So there is a study, and which says service life of this fusion based epoxy coated with the steel rebar. So you can see this is the uncoated rebar, and this Spire is the coated rebar without damage. And again, when you have this coated rebars exposed to the atmospheric conditions being light in the site for long duration, there will be a degradation due to ultraviolet sunrise, and there will be a degradation due to direct sun exposure as well. So this indicates the no damage, and this indicates ultraviolet damage, and this SD condition basically indicates the surface damage of your rivers. So when you have surface damage and ultra high violet exposure, then the performance is going to be less compared to your uncoated bar itself. So the probability of the failure with respect to the age of the structure will be more when you have damaged epoxy coated rebars, or when you have exposed epoxy coated rebars. So the rebars with coating will perform better only when you are taking care of it properly with no damage. So it is like when you can give a proper control or care to a rebar, then you can go with epoxy coated rebar. If you cannot take care of it, then it's better not to use your rebar, and you can go with the conventional rebar for the purpose, so that the consequence will be less compared to the consequences of using rebar with damages. So here you can see some premature corrosion happened due to such poor practices of epoxy coating bars. The more damage to use damaged epoxy coated steel bars than the conventional uncoated steel bars. In addition to that, nowadays we are working a lot using this GFRP bars. The GFRP bars technology is something that is being the regular construction practices in many developed countries, but in our country we are yet to adapt such GFRP or FRP bar usage in our construction practices, and we have building code that is being in um, process soon, that will be released, which gives you the specifications and test methods for GFRP bars from BIS. So you can see here how do you manufacture the GFRP bars. You have the fibers, you have polymer matrix, and you place these things together and you get the FRP composite. So unlike steel rebar, the conventional rebar, your FRP bars are a composite material. So it depends on the material properties of the two different you know matrix of fibers and polymers. But the advantage is that you can have less weight. The GFRP is lightly weight, and it can be customized to any lengths and bends and shape. And this is one of the alternative solution when you think the corrosion is the issue. So it's non-conductive to electricity and heat, and brittle, non-metallic, and it concern is that the chemical attack that it will be undergoing. So when it is a highly alkaline environment, there the performance of GFRP is a bit uncertain. Otherwise, where you feel the corrosion is the issue, the GFRP bars can be used. And there are some projects who started using GFRP bars for non-structural applications. Soon this can be used in structural applications as well with certain conditions. Right? So let us compare the cost variations between the different rebars. So when you have the conventional steel rebar, the cost ratio will be 1. So as the the performance increases, if you are providing a corrosion resistant steels or coated bars or galvanized bar or GFRP bars, the cost will tend to increase. When you use GFRP bars, you may have 3 times the cost of your conventional bars. When you use solid stainless steel, the cost will be even more higher. So these things can be chosen having the capital cost in mind and having the importance and significance of the performance of the structure in mind. So though you spend more money in the initial stage or capital cost, you may save a lot of materials considering the overall cycle of the structures. The durability and life cycle cost must be also be considered while choosing the materials. Right? So this is the key thing to take out. So you need to know which material performs better for certain applications. So you should not think about the cost as one of the criteria in the initial stage, because you should look at the holistic performance of your structures to look at the life cycle cost. So I'll just briefly touch upon a concept on the pre-tension concrete aspect. So far we have looked at the various materials that we use for the constructions in point of concrete and steel. So now let's see what is this pre-stressed concrete applications. So some of you might be handling pre-stressed concrete technology. So you can see the evaluation of pre-stressed concrete technology, how tremendously it has evolved from 1950s to the current scenario. So nearly 65% of all new bridges are constructed using pre-tension concrete technology owing to its advantage of having long members, slender members, and making, reducing the cracks. Obviously. But then we have observed certain few issues with pre-tension concrete system itself. This is one of the bridges in this connecting the Pune to Mumbai that has lot of such shear cracks formations in all the girders almost all along the length of the span. So what could be the reason? So we cannot, unless we examine these structures, we cannot provide a solid reason. But then by looking at the possibilities, it could be due to poor construction practices, or especially since it's a shear region, the shear contribution will be less. So that could be governed by the transmission length and bond strength aspect. So if this is the case for the pre-tension concrete bridges, how about the similar scenario for other pre-tension systems? So other common application of such technology is in hollow core slabs, which is being used in the commercial buildings or high-rise buildings. So one thing that we are observed is that the code recommendations are not updated. So the existing codes or test methods have its limitations. So we need to come up with a method which can estimate better transmission length and bond strength so that such scenarios can be controlled. Similarly, this is the case for the railroad ties. The only difference is that the diameter of the strand that will be used in this railway ties will be lesser than the one that will be used in bridge deck and the buildings. And even here in this railroad ties, we have observed a lot of issues, seating bottom test due to poor bond performance. So what we observed is that the bond mechanism in pre-tension concrete system is mainly governed by adhesion, friction, and mechanical interlock. And when you talk about the strands, the mechanical interlock plays major role. So the difference between the plain wire and strand is that, so when you have this strand, the after peak, the resistance to the slip will be enhanced better. In the friction, the effect will be due to the wedge action at the end. There will be a higher effect that enhances the confinement, and you will be having a mechanical interlock as well. So the helical shape of the stand would tend to increase the strength. So in pre-tension concrete system, you have a bed here and you have a stand, and you will be stressing using the jack, and the stress will be transferred slowly from the end to the member over the length. That length is called transmission length. The length required to transfer the stress from 0 to effective pre-stress, and then the stress will be maintained. So now this structure is going to expose to the environmental service condition. Under the service condition, the stress will be activated, and there will be increase from the effective to ultimate stress. The length required for reaching this effective to ultimate is what? Bond length, and together the length required to reach the ultimate stress is what? Development length. So you might be knowing the development length requirement for achieving the complete utilization of your strength, or to develop the strength required, especially for the flexural member. So inadequate bond will result in increased transmission length, and when it is being increased, and that will reduce the shear and flexural performance in the critical regions. Especially in the ends, the anchorage reinforcements are crucial. That depends on the transmission length of your member. So the major factors that influence the transmission lengths of the compressive strength of concrete, stress level, diameter of strand, surface condition of strand, releasing methods, and time-dependent effects. But when you consider the coded recommendations, not all the factors are being considered, especially the Australian, Canadian, and Indian codes. So that talks about the transmission length with respect to only the diameter of the strand. So if you change the concrete strength, or if you change any one of these factors, you will be end up having the same transmission length, but the real scenario is not the same. So it is using these equations are not appropriate, whereas the Euro code and FIB code that gives you the scenario of all the factors being considered which would influence the transmission length. So adapting this would be more effective or approachable. But then we need to look at the factors that are considered, is it good or bad. So sometimes we tend to add more factor of safety so that if something goes wrong, there will be something to take care of this structure. That's how the design code works. But that is not always true, and especially for the pre-tension concrete system, we should not work in that point of view. I will tell you why. So in pre-tension concrete system, underestimating and overestimating both are going to crucial. Of course, we all know we should not underestimate the required parameter. Will be short of the safety factor. Whereas when you overestimate it, we think that is adequate to provide enough safety, but that is not for the pre-stress case. So here is the scenario collected from the literature and then the research. From there, it indicates that compressive strength has a significant influence on the transmission length. Likewise, surface condition also has significant influence on the transmission length. And I'm talking about the transmission length. I'll tell you how to measure the transmission length also. It is basically you are measuring the strain on the concrete surface. That would be using strain gauges or using Diemer pins or using DIC techniques. So from this, you measure the change in distance and then you calculate the strain and you plot the graph. I'll just illustrate you the waves in sequence at which the process used to prepare these specimens. You have a pre-stressing bed and you have a mold placed. Then you pre-stress the strands using the hydraulic jack and other accessories required to activate the stresses, and you concrete it and cure it. Then you cut the sample. And in this method, I placed inbuilt DMF pins, which is required to measure the strain on the concrete surface. You will not be measuring the strain, you calculate the change in distance and then you calculate the strain. So these are the ways that in which strains are obtained. And from the obtained result, so you can see the 95% average maximum strain method is used to get the transmission length using various strength of concrete. So it is summarized in this plot. This indicates when you change the compressive strength, the transmission length is gradually decreasing. So from 23 to 45 MPa of the strength at the time of release, the reduction in the compressive strength is about 36%. So likewise, the stress effect is also induced, and from this result, the bipolar model is proposed to the code to enhance the determination of transmission length. So similarly, based on the model, this was compared with the other standards as well. From the comparison, it is understood that our Indian code underestimates the values significantly, and there are codes that overestimate the values, and there are codes that overestimates, but that is not being constant and that is not reliable all the time to go with. So yes, underestimation and overestimation of the transmission length is not always good for pre-tension concrete system. So let us understand how the bond mechanism is being affected. For conventional strength concrete, you all know that we can do the bond strength by pulling a pull out test, casting a simple cube specimen embedded in the cube specimens with embedded rebar, and this will be placed in one end and you will be applying a pulling force at this end and try to pull the rebar out from the concrete. The bond criteria, failure criteria used for the rebars are 2.5 mm slip at free end, and first slip at the free end will be measured, or can these be adapted for the stands? It cannot be adapted. There are people who researchers worked on several methods to come out with the specific test methodology that can be used for pre-stressed concrete. So the Mustafa test method is for a complete concrete block in which strands are embedded, and then jack will be placed to pull out the strand. But here the disadvantage is that the strands are not pre-stressed. And there is a test method STMA 1081. Again here the scenario is use the unstressed strands in cement grout, and here also it is not mimicking the scenario of pre-tension concrete system. So then Ikara test method come up with some imaginary parts. So it is adapted anchorage measurement access method. So this setup is basically replacing the stiffness of the entire remaining length of the specimen. So this involves a lot of complications and is expensive also. So we decided to come up with simple test method for determining the bond criteria. And based on that, the simple test method is proposed, and 1 meter long prison specimen is cast with stressed member. So the stress level is 0.7 FPU, and then the whole setup is placed in this MTS machine to do the pull-out test. And this end is fixed, and then when it is being moved here, the strands are being pulled out from this end, and two measuring devices are placed at the ends to measure the slip on the end of the members. Two different pre-stress levels were considered, two different embedded lengths were considered. From the testing, we understood the behavior of the strands in concrete, and from the behavior, the failure criteria for the test methods are also come up with and proposed. So we understood that when the tensile stress increases, bond stress is increased, and then when the length is increases also, bond stress is being increased. So this is for the short span, this is for the long span. So from this, when we use the effect of LE, the effect of the defining method is very good. Instead of 2.5 mm slip, you consider the change in point where the behavior changes. So by considering that, we could eliminate the total embedment length, and we can eliminate the effect of pre-stress. So those things could be minimized. So if you look at the bond strength definition using 2.5 mm slip and yield stress method, here the 2.5 mm slip and yield stress methods are giving almost the similar results. So when using 2.5 mm slip method, so the hollow regions are basically 2.5 mm slip method. So the strength, the effect of the length or compressive strength cannot be ignored. Whereas if you consider the yield stress method, there is like bend over point to consider the change in moment, then the effect of the length and pre-stress levels are being minimized. So in that case, the the scatter is also lesser, and the effect is also achieved better. So from the complex test method, we could propose some simplified test methods using this 90% yield stress method. And from this, we could understand some bond failure criteria at the interface as well. So for helical shaped strands embedded in concrete, the bond failure is different. So you have a shear key formed, and as the strands are being pulled out, these shear keys also getting deformed, and partially the shear keys are getting cracked at the initial stage, and here you can see the shear keys are completely cracked, and this is going to kind of give you a pipe formations in which the strands are going to pass through smoothly. The damage of concrete key, a smooth path resulting in pull-out failure. So from this, to summarize, is that we looked at several modern techniques that enhances the concrete properties, and material specifications and testing specifications required for steel rebars as well as the FRP rebars, and then the use of application of PTC systems, and then test methods for bond testing for pre-tension concrete systems, how to reduce the complex method to simplify a standard test method that anyone can adapt to ensure the quality of the bond inside. So that I'll conclude the presentation, so we can ask for any discussions or interactions.
Well, that's a wonderful session, madam. We want to thank all the participants of this program, and I would like to, this session is open for any queries.
Hello, good morning, madam.
Yes, good morning.
Yeah, madam, you told that the high performance concrete, madam, that is a grade of above 120 grade. So, is there any codal provisions you will going to follow to design the high performance concrete, or that is fully based on the trial and mixes, madam?
So So for high performance concrete up to M80, our regular code is
Yes,
there.
madam.
So for the ultra high performance concrete, the code regulations are in process. So soon we will be having it. There are certain codes, ACA codes can be followed, and some literatures can be referred. But currently we don't have a specific code to be followed for UHPC.
Yeah, okay, madam. And one more thing, in the case of self-healing concrete, what is the minimum grade of concrete we will going to opt, madam?
Self-healing concrete, I'm not currently working on it. So to start with, maybe you can start with M40, M30,
Okay.
the minimum grade of concrete, and you can enhance it better.
Yeah, okay. And in the case of special types of mineral admixtures, you are mentioned that one image that is POFA, madam, POFA, POFA. POFA is one of the image you are shown in the like fly ash, GGBFS,
Okay,
and
that is one of the mineral
SSS.
admixtures that we use.
Okay, okay.
So it's
And you
palm
are
oil
showed that
fuel ash, palm oil fuel ash that we can use as one of the supplementary cementitious materials that has a tendency to react and produce hydrated particles.
okay, okay, madam, you are showing the majority of the cuts images are very good, madam. But as I watched you are mentioned also the years, madam. I think some images are around 2000 and 2013. Already one decade is over, madam. So
Yeah.
after that, is there? I think so much of what we call the improvement is. I think they are made.
Yeah, so the sustainability is something that we give attention in the recent times. So we really
Yeah,
need to work a long way to go and reach there. So we need to do a lot of research and come up with some findings to update things. So it has to be updated.
okay, okay,
So a lot of
madam.
participation from industry and academia should take part and do things to enhance it further. And in India, we really lag certain things compared to the developed countries. So we are learning the good practices that is being adapted there, and we are trying to implement here. And more
Yes,
next in
yes.
5-10 years, you can see a huge transition in the construction industry field.
Yes, madam. And in the case of 3D printing concrete also, I think it is not it is not an economically. It is you are
It
already
is economical.
mentioned
You have to
some
think. You have to think the holistic service life of
SS,
the
madam.
structure. Initial cost alone, if you look
I
at,
saw one image where you are posted the Indian Post Office. That is the
yeah,
1200 square feet and the cost is around 27 lakhs.
yes,
Mm, they are not sustainable. Okay, okay. Okay, madam. Thank you. Wonderful session, madam. Okay, thank you.
thank you.
Madam, one more question. One of our participant has been posted.
Yes,
Please
sir.
tell us about the hardened properties of 3D printed concrete.
See, hardened properties of 3D printed concrete are being in saving. So we do check the fresh properties, and compressive strength of the concrete will be tested. And a lot of research is going on to come up with the defining the mechanical properties of 3D printing concrete. And we now recently BIS is working on developing the properties for 3D printing concrete as well. So once the code has come out, then we will get a clear idea of what or how to, what properties that we have to look at, test methods to adapt to check the specifications on this.
Good morning, madam.
Hello,
Am I
good
audible?
morning. Yeah, you
This
are
is Professor
audible.
Jagannath Rao. I have two questions.
I am yes.
Yeah. This is a wonderful session that you have covered, given an overview of all the sustainable concretes with pozzolanic materials and fibers, and of course the steel reinforcement with the various coatings and their behavior and the different coatings and all,
It is.
covering very neatly, elaborate way. That's wonderful. I have two queries basically. One is, what material is used for the 3D printing right now? There is one question. And as far as
Right
the
now, there's a,
uh,
yeah. The conventional cement particle, cement and then fine particles, fine aggregates will be used. So the coarse aggregates we typically avoid, and with admixtures, we need to use this full precipitator and then the viscosity modifying agents because the flowability needs to be controlled.
Yes.
So admixtures we will use, and then the cement, the main ingredient, and a bit of some amount of water and admixtures. It's the main composition that will use the 3D printing coating.
Okay. So cement, fine aggregate,
And
and VMA. That's all. Okay. And superclizer
sorry,
is
sir?
required. It is PMA and superclazers in addition to cement and fine aggregate. You are using them.
Yeah, viscosity.
Okay. Okay. And second one is you're talking about in one of the slides in the earlier slides about the energy, embedded energy or energy component. Um, Different materials are compared, and the concrete is very low compared to all other materials, steel and other materials. But I have one question that the quantity to be used also is to be compared because 1 ton of
Yeah,
steel,
this is
suppose
with
if you
respect
use
to quantity only.
concrete, maybe 100 to 200 tons is required for the same performance. So that is one point I would like to get clarified.
So this is with respect to the quantity or which it is being used, the amount of volume. So comparing to that, the energy released was compared. So as I mentioned, concrete is the highest consumed material next to water. So imagine the production of the concrete and then the cost involved with it. So in that way, it is compared with the other material. So I compared with titanium and aluminum and the cost and production rate for those things and the cost and production for the concrete.
Okay. So thank
Did
you.
I answer your question? Is this what you asked?
I think you compared the energies, energy levels,
Yeah,
energy, embedded
that is
energy.
taken from
That one.
literature to sensitize the amount of concrete that is being used and then the amount of energy required for the production.
Yeah, for the production, that's fine. If you compare literally 1 ton of cement and 1 ton of steel or aluminum or other material, if you compare concrete, it requires very low energy. But the quantities when you use in the market, huge quantities are required. For example, a steel section of I section, whatever the load carrying capacity is, that correspond to that concrete, it is more than 10 times it requires, more than 10 times or 20 times it requires the quantity to carry the same load or
Yeah,
something
I
else. So
agree.
that needs to be taken into account
Yes.
for sustainability. Right, madam? Thank you.
Yeah, thank you.
Good morning, madam.
Hi, good morning, Swanjana.
Actually, I want to know whether there are any softwares.
Your voice is not clear. Can you please be?
Are there any softwares related to the durability assessment, that is corrosion, say about ingress of your
There is one software in the name of Life 365. So that it's a free downloadable software. So that gives you, if you have a concrete and rebar, and if you provide the a coefficient of the a diffusion coefficient, and then the exposure conditions or the cover depth, and that will roughly estimate the service life of your structure. So
there
you
is a
can explore
software.
that version. Yeah.
For the chloride ingress, also software is available. For
So it's
chloride
not
ingress,
to
that is
detect the
concrete.
chloride ingress. Based on the chloride content or the chloride ingress, you can detect the remaining service life of the structure.
Okay. Madam, kindly name the software, madam.
Life 365. So I can post it here. So Life 365 is the
Okay. Thank you, madam. Thank you
software.
very much.
Madam, another question. Like bond strength between the layers for 3D printed concrete.
Yeah. That is one of the things that is still need more detailed study. So far, we are getting so that is based on the yield stress and the shear strength between the layers. That is adequate enough, but how well that can be maximized or enhanced, that is all in study.
So any queries? Participants, can you please, if you have any queries, you can ask. Ma'am. Okay, madam. I think there is no any questions regarding this seminar.
Okay, great.
Okay, madam. Thank you.
Fine, sir. So you please share the feedback as well with me as well.
Yeah, sure, madam.
Okay. Thank you.
Thank you, madam. And tomorrow also we'll start the session at 11 o'clock.
Fine. I'll take leave, sir. Thank you.
Okay, madam. Thank you.